quadratic equations. You really should understand first the look of the graph of a quadratic equation. And what I have drawn on the board here is the graph of y equals x squared. And I'd actually like you to turn to page 634 in your book with me, because there are several things I'd like to point out to you there. First of all, again, this is the graph of y equals x squared. And I'd like to basically read right from the book for you, because it's got some really important information. And it's below example 1 in section 5. It says all quadratic functions have graphs similar to the one as I've got on the board, and they're called parabolas. So think of a satellite dish, if you will, and quadratic equations are a U-shape. Sometimes they open up like this one, and sometimes they open downward, and we'll see as we go along when they open in each direction. It says they are cup-shaped curves that are symmetric with respect to a vertical line known as the parabola's line of symmetry. In this case, the vertical line is the y-axis. I have this equation, y equals x squared. If I were to fold this as a piece of paper in half, I get a reflection about that y-axis, or its line of symmetry. In the graph of f of x equals x squared, the y-axis, or the line x equals 0, is the line of symmetry. The point 0, 0 is the vertex of this parabola, and what we're going to be asking you to do throughout these next two sections is to find the vertex, to find the axis of symmetry, and to find a maximum or minimum point. And we'll talk about that, I believe, later in this section. The other thing that I'd like you to know about the graphs of quadratic equations, this is the graph of y equals x squared, and basically you can graph any equation with a table. In other words, for this particular equation, if I put 0 in for x and square it, I get 0 out for y. If I put 1 in for x and square it, I get 1 out. And if I put 2 in for x and square it, I get 4 out. Well, likewise, if I put a negative 1 in for x and I square a negative 1, I'm going to get a positive 1 out. And when I put a negative 2 in for x and square it, I'll get a positive 4 out. And these are the 5 ordered pairs that I've plotted for this graph right here. Graphs that are quadratic in nature, that just have the x squared term, will only vary now by how thin or how wide they are. And if you would look at below example 1 in this section 5, you'll see that if the coefficient in front of the x squared term is a number that's greater than 1, they've got an example of 2x squared, that the parabola is going to be actually thinner. Still going to have a vertex right here, still going to have the same line of symmetry, but it's going to be thinner. And as the coefficient in front of the x squared term is a value that's less than 1, between 0 and 1, it's going to get wider. So the parabola is going to look like this. It's going to be a very large U shape. They show the graph of y equals 1/2 x squared. If you would look also on page 635, in the blue box towards the bottom, it says the graph of f of x equals ax squared, or y equals ax squared, is a parabola with x equals 0 as its line of symmetry. The vertex is its origin. So that's always the case for y equals x squared, or something that's got a coefficient. If a is greater than 0, the parabola opens up. So that's what we have here. If the coefficient in front of the x squared term, for example, if I had y equals a negative x squared, then that parabola is going to open downward, like I've shown right here. And any coefficient in front of that x squared term, and I better put that right down here, this is the graph of y equals a negative x squared, it will always open in a downward direction like this, and that's what they're saying there. If a is less than 0, the parabola opens down. If the absolute value of a is greater than 1, the parabola is narrower than this, and what we mean is if this is a 2 or a -2 or a 3 or a -3 or a 100 or a -100, it will be a very narrow parabola. But then in the last line it says if the absolute value of a is between 0 and 1, the parabola is wider. It will look like this, a very large U shape. Or if it had a negative value between 0 and 1, it'll look like this. Let's go on in our next example, and we'll graph one. I'd like to look at the graph of y equals 5x squared, and I'd like you to notice the notation. Either of these is appropriate. Y equals 5x squared, f of x equals 5x squared are the same. It's the same notation for a function. And either of these represent the same thing. When I ask you to graph these, basically I'm asking you to pick some values for x, put them in, and find out what y is equal to. Well, in these kinds of problems, picking a value like 0 for x is ideal, because 0 squared is 0, and then multiply that by 5, and you get an output of 0. Please remember to do the exponent first. If I put in a 1 for x, I have 5 times 1 squared. Well, 1 squared is 1, and 5 times 1 is 5, so that's what I'm expecting here. And when I put in a 2 for x and square it, I get 4, and 4 times 5 is 20. Likewise, when I put negative values in for x, when I square those, they become positive. So a negative 1 squared is a positive 1, times 5 is 5, and I'll get an output here of 20. The graph here, I like to start with its vertex at 0, 0. And would you notice that I marked off on the y-axis increments of 5 because I had to go so large on the y-axis? But I kept the x-axis marked off in increments of 1. And so the next ordered pair I'm going to graph is x is 1, y is 5. That's right there. X is 2, y is 20. And then over on the left of the vertex, x is a negative 1, y is a positive 5. X is a negative 2, y is a positive 20. And here's that U-shaped curve again for the graph of y equals 5x squared. And I'd just like you to notice the biggest thing. The vertex is at the origin. That's because all I have is an x squared term. I don't have in this quadratic equation a term with x in it or a constant. That will change it drastically. Would you notice that the line of symmetry is the y-axis, or the line where x is equal to 0, again for this reason? And would you notice that because I have a 5 in front of the x squared term, that the graph of this equation opens upward? This time I want to graph a quadratic equation which is similar to the last in that I just have an x squared term, but the coefficient in front of the x squared term is negative. And it's also a fraction too, so I would like you to see the difference here. I'm always going to choose, at least for right now, these values for ordered pairs because I know it's going to be symmetrical about the y-axis because I only have an x squared term. And when I put 0 in here and square it, I get 0, and I multiply it by 1/4, I get 0. When I put in 1 and square it right here, I get a positive 1. And 1 times a negative 1/4 is a negative 1/4. When I put a 2 in, and I'll write this one down, and I square the 2 squared is 4, so I have a negative 1/4 times 4 over 1, if you'll allow me to do that, and the 4's cancel out, and what I have left is a negative 1. When I do this in reverse on the other side of 0, if you will, when I take a negative 1 and square it, I get a positive 1 again, and I multiply that by a negative 1/4, and I get that same value, and of course the same thing happens here. Let's graph these ordered pairs. Here's my vertex, x is 0, y is 0. When x is 1, I get a value of a negative 1/4 for y. So I'm going to call this a negative 1 right here. So 1/4 is about right there. And when x is 2, y is a negative 1. So that's this point. And on the other side, when x is a negative 1, y is a negative 1/4. And when x is a negative 2, y is a negative 1. And here is the graph of the parabola that represents y equals a negative 1/4 x squared. Would you notice a couple of things here? It opens downward because of the negative number in front of the x squared term. That's always going to be the case. Would you notice its line of symmetry is about the y-axis, or where x is equal to 0. And this curve has a maximum point. We're going to be looking at finding minimums and maximums. If I've got a negative sign in front of the x squared term, then it's going to have a maximum point. If I have a positive sign in front of the x squared term and it opens like this, then I'm going to have a minimum point. So we'll be talking about that as we look at the next few problems. Quadratic equations can often be written in the form of a binomial squared. As a matter of fact, I have written here the next problem I'd like to graph. It's f of x equals x plus 1, that binomial squared. The reason we do this is to allow ourselves to find our axis of symmetry, our vertex, our minimum, our maximum point. It makes it very, very simple because there's a pattern that repeats itself. And so the kinds of problems that we're going to look at now in the next couple are in this form. It is where I have a constant in front of the x squared term, but I've factored that trinomial into this binomial square. But anyway, an a value is the coefficient of the x squared term. If I FOILed this out, I would have an x squared term. So I'm going to use a constant of 1, so I've not put anything in front of this binomial. And I'm going to take a look at the graph of this function. So first of all, you know how I picked a few minutes ago, I picked 5 values to graph a quadratic equation? I'm going to ask you to pick a value for x that will make this, what's inside the parentheses, equal to 0. Well, that's a negative 1. A negative 1 plus 1 is 0. That's the first value that I'm going to graph, because I know then that a negative 1 plus 1, which is 0, and 0 squared is 0. It's an easy point to find. That's why I picked that one. And then what I do is I go on either side of that, up a couple and backwards a couple, and find the y values for those values for x. So when I put in a 0 for x here, 0 plus 1 is 1. 1 squared is 1. When I put a 1 in, 1 plus 1 is 2. 2 squared is 4. It just makes it very convenient, very small numbers, very whole numbers, very, very nice to work with. A negative 2 plus 1 is a negative 1, and then I want you to square that. It gives you a positive 1. You're going to see with parabolas that you get reflection about this point. So where I had 1 here, I'll have 1 there. When I put a negative 3 in for x, a negative 3 plus 1 is a negative 2. And when I square that, I get a positive 4. Again, here's that reflection. So that's why I'm patterned about this. Now I'm going to plot my vertex first. When x is a negative 1, y is 0. That's that point. When x is 0, y is 1. When x is 1, y is 4. And then on the left-hand side, when x is a negative 2, y is 1. And when x is a negative 3, y is 4. So I go ahead now and I sketch that quadratic equation. Because there is a 1 in front of this binomial, it opens upward. I'd like you to notice, if you would please, this line of symmetry. You're going to be asked for the vertex in these problems, and you're going to be asked for the line of symmetry. And so the vertex is the x value, in this case a negative 1, where and your y value, so I want the ordered pair. I want the minimum point of that parabola. And in this case, because I've written this as a binomial squared, it's going to lie on the x-axis. And then the line of symmetry is going to be that value right there, always. It's the x value of the vertex. It's going to be the value in this case where x equals a negative 1. That line represents x equals a negative 1. And that's all you need to tell me here is its vertex. Again, gotten by making this equal to 0, you'll find that vertex. And the line of symmetry is always this point because that's at its vertex. Let's look at another quadratic equation. Here's the equation I'd like to look at. F of x equals 3 times x minus 2, that quantity squared. And I'd like to ask you again to focus on the value for x that will make this, what's in the parentheses, equal to 0. Well, that's a 2. And then I'm going to look at 2 values on either side of this to get a good look at the parabola. So 2 minus 2 is 0, 0 squared is 0, 0 times 3 is 0. That is going to be my vertex all the time. In this case, I would say the vertex of this parabola is where x is 2, y is 0. I need you to start noticing something. When I can get a quadratic equation in this form, my vertex is going to take the opposite of this sign for my x value. See, I have a minus 2 here. My vertex for x is a positive 2. Notice that from now on. Then I'm going to look at using a 3 and a 4 because they're on the right side of that. So 3 minus 2 is 1. 1 squared is 1. And then 3 times 1 is 3. When I put in a 4 here, 4 minus 2 is 2. And I'll square that, that's 4. And then I'll multiply that by 3, that's 12. And then I'm going to try the values that are less than 2 incrementally. So when I put in a 1 here and subtract 2, I get a negative 1. I'll square that, that's a positive 1. I'll multiply that by 3, that gives me 3, that gives me this value. And automatically I can see I'm going to get 12 for that value. Again, here is going to be my vertex. X is 2 and y is 0. On either side of that right here, x is 3, y is 3. Here's one of the ordered pairs. Over here, x is 1, y is 3. I don't have enough room to show this ordered pair and this ordered pair, but I do know that this parabola goes up like this. It's a little bit thinner because I have a 3 in front of my x squared term instead of a fraction. I see that my line of symmetry is right here. And so you would say to me that your line of symmetry is where x equals 2. So lo and behold, look at this right here and this right here. They match. The vertex, the x value for the vertex and the line of symmetry are the exact same thing. In a bit, we're going to ask you what the minimum value is, but we're going to move it off the x-axis in order to do that. I need you to look at an equation in this form. The 3 makes it open up. The minus 2 gives me a positive 2 for the vertex where y is equal to 0, and that's my line of symmetry. That is a pattern that is always going to occur. Let's now look at the graph of a quadratic equation. F of x equals a negative 2 times x plus 5, that quantity squared. And let's just decide what the axis of symmetry is, what the vertex is, if it opens up or if it opens down, and let's just sketch this. Now, mind you, when you graph this for me, I would like you to give me some ordered pairs. I would like you to complete the table, but I want you to see the pattern now. First of all, the coefficient in front is a negative 2. That means that I'm going to be looking at a parabola that opens downward like this. Also, I don't know if I mentioned this, you should be putting arrows on the ends of your parabola to state that they continue on infinitely. The opposite of 5 is a negative 5. That tells me that the vertex is going to be at a negative 5 comma 0, and the line of symmetry is going to be at a negative 5 as well. So if I come on over here to this point, this line right here is my axis of symmetry for the graph of this parabola. Because of the negative sign, I know it opens down, and because this number is greater than 1, its absolute value is greater than 1, it's a fairly skinny parabola, if you will. Now again, I didn't plot any ordered pairs, but that's a look at this equation without doing anything, without completing any tables. I could have done that. I could have picked a negative 5, put it in there for x. Negative 5 plus 5 is 0. 0 squared is 0. You know, we get 0 here. And then I could have put in a negative 4 and a negative 3 and a negative 6 and a negative 7 and gotten similar results like I've gotten in the past. I'm not going to bother. But had a look at this picture and a look at this vertex and this line of symmetry. You need to be able to do, look at this equation and give me the vertex and the line of symmetry and graph it and create a table of values. Okay, this is the function that we're going to graph now, and what I need you to see is that we're going to add, and I forgot the letter that we use, I believe it's the letter C right here. I'm going to stop and check my book for just a minute. I'm sorry, actually we use the letter K as a constant, that's why I wanted to use the letter C, to add to a quadratic equation. So it's going to affect some of these things right here. We're going to look for both a vertex, a line of symmetry, but now we're going to look for a maximum or a minimum value for this parabola. So I'm looking for all three of those things. A couple of things I want you to know. That if you write this quadratic equation as a binomial squared, that the opposite of this value right here, that negative 2, will always stand for its line of symmetry, and the negative 2 will always be the x value in the vertex of this quadratic equation. Now, what I would really have you do is I would have you create this table again, and I would have you start with the negative 2 and put it in there for x, and negative 2 plus 2 is 0, and 0 squared is 0, but then you have to subtract 3. That right there is the vertex of the equation. And so, well, I won't graph that yet. Let's go ahead and look at some points on either side. So a negative 1 and 0, and then a negative 3 and a negative 4. When I put a negative 1 in here for x, a negative 1 plus 2 is a positive 1 squared minus 3. 1 squared is 1. When you subtract 3, you get a negative 2. When I put a 0 in here, 0 plus 2 is 2. So I have 2 squared, which is 4, and subtract 3 gives me 1. And when I do the same thing over here, a negative 3 plus 2 is a negative 1, but I'm going to square that, so that's a positive 1. And then I subtract 3, and I get the same value, and here I'll get the 1 that I got down there. So let's graph this. X is a negative 2, y is a negative 3. That's the vertex of this parabola right here, because I was able to make what's in the parentheses equal to 0. When x is a negative 1, y is equal to a negative 2. That's this value. And when x is 0, y is 1. So here's that value. So it looks like this parabola goes like this, and I expected that because the number in front of the parentheses is a positive 1, If it's positive, it will open upwards. When x is a negative 3, y is a negative 2. That's this ordered pair. When x is a negative 4, y is a positive 1. And in this direction, the parabola will go up like that. What I need you to tell me in all of these problems is what its vertex is. And I need you to know that the vertex is going to be at this point right here, where we made what's in the parentheses equal to 0, and that value right there will define the y value of the vertex. So a negative 2 comma negative 3. The line of symmetry is this negative 2. That's because this reflects about that point right there. And the maximum or the minimum, all I'm looking for is the y value right here. And right here on the y-axis, I have a y value that's equal to a negative 3, or we would say, in this case, we would probably say that the minimum output for this function is a negative 3. Just notice this. Now, I hate to do this, but these 2's match, these negative 3's match, and that will always, always be true. Okay. If we look at this function that we're going to graph and we think about what we've been talking about so far, the opposite of this value, a 1, is the line of symmetry. That is the value I'm going to put into this equation at first in order to find my output. But it also tells me that I expect this quadratic equation to reflect over that line right there. When we do put this in, 1 minus 1 is 0. 0 squared is 0, 0 times a negative 4 is 0. Then we add 3 to it. That right there again is the vertex. So again, I would have this already at this point. Please remember that I said to you that the x value in the vertex is the opposite of that. The y value is always the same as that. Next, I'm going to look at values on either side of that vertex. So when I put a 2 in here, 2 minus 1 is 1. 1 squared is 1, and then I'm going to multiply it by a negative 4. So I have a negative 4 here, plus 3 gives me a negative 1 is my output. When I put a 3 in here, 3 minus 1 is 2, 2 squared is 4. A negative 4 times 4 is a negative 16. When I add 3 to that, I get a negative 13. That's going to be my output for y. And vice versa, then I'll have a 1 here and a negative 13 here. And I'll plot these ordered pairs. The center one right here, when x is 1, y is 3, so that's right here. When x is 2, y is 1. When x is 3, y is a negative 13. It's way down here somewhere. Over here, when x is 0, y is 1. And when x is a negative 1, y is way down here somewhere. So it's a parabola that goes like that and like this. All right? Again, I'm looking for this vertex. I have found it. It's where x is 1, y is 3. The line of symmetry where this reflects is where x is equal to 1. And the maximum value in this case, before it was a minimum, the maximum value is y is equal to 3. And we'll just say max is 3. This is the conclusion of section, the 5th section in this chapter, graphing quadratic equations, when you have either just an x squared term, or you have this written as a binomial squared plus or minus a constant with a coefficient in front. In the next section, we're going to graph quadratic equations where they're in standard form. And what we're going to do is we're going to force them into this form by completing the square. You learned how to complete the square at the beginning of the chapter to learn how to solve a quadratic equation.